Hello everyone. In this example, we're going to examine a few resistances connected in series, and we're going to learn how do we calculate the equivalent resistance plus any other element that we need in that circuit. So let's look at this particular circuit right here. We have a 50-volt voltage source exciting four resistances connected in series, and we are asking for the amount of current I that we are drawing out of that source. And we're also asking for the power that this voltage source is delivering to the circuit. Now, this is a very simple case, but still, let's go step by step to make sure that we all grasp the picture here. So the very first thing that you're probably tempted to do here, and it would have been correct and actually the easiest path forward, is to combine those four resistances that you see into a single one. In other words, probably the most tempting step here is to say that, look, I can redraw my circuit by putting the same voltage, 50 volts, and now, instead of having these resistances, I will simply replace them with one single resistance, Req. After all, if I do that, I will have exactly the same amount of current flowing, but now it's much easier to find I, because the current I that I need to find, or let's put it actually with a capital I since that's what I'm using here, the current I that I need to find is nothing else but 50 divided by the equivalent resistance, and also the amount of power that this source will deliver to the circuit will be nothing else but the source itself, so 50 square voltage, over the Req. So really, at the end of the day, this calculation will boil down to finding the equivalent resistance. Indeed, this is something quite easy to do. Just by applying the equation we have, I can write that Req is 5 plus 15 plus 12 plus 8, and this will be equal to 40 ohms. And therefore, since I have my Req to be equal to 40 ohms, I can do the math, and I will find out that my current I will be equal to 1.25 amps, and the power that the source is delivering will be equal to 62.5 watts. So this all appears simple, and it is correct, but one thing I would like to caution you is the step that we did right here, meaning drawing the equivalent circuit by saying, oh, all of these resistances are in series. In very simple cases like this one, it's almost obvious, even to the untrained eye, that these resistances are in series. And because we start by learning so simple circuits, you may be tempted every time you see something that looks like this to immediately say, oh, these things are in series. I would like to caution you and always ask yourself, are these resistances truly in series? The only real way to examine this and to convince yourselves that you're not making a mistake, and indeed this combination is a serious one, is by asking yourself the following question. Is the current that flows through the first resistor necessarily equal to the current that will flow through the next one? If the answer is yes, then you're definitely guaranteed to have a series connection, because the series connection is by definition one in which the current is the same. It's not the one that simply looks like it's connected in series. It must satisfy this condition. A series combination, as we learned in theory, must satisfy that the amount of current is the same. So once again, ask yourself, is the current that entering one resistor necessarily equal to the current that will enter the next one? If there is another choice for the current, then the answer is no, they are not in series. For example, if I had another resistor here, perhaps connected like this, then clearly this 5 ohm resistor and this 15 ohm resistor would not have been in series, because the current that enters the first resistor now has a choice to either continue through the 15 ohm or actually go down. So again, in very simple cases like this one, it's quite simple to tell. But as we get more and more familiar with more complex schematics, ask yourself this question: is the current necessarily the same? then two resistances will definitely be in series, even if they don't immediately appear to be. So thank you very much for watching this video. I hope you find these remarks useful. We will see you next time.